Okay, Assalamualaikum class. So let's do some revision for your exam. So the first question is about the DC analysis of the diode. So it consists of your 10 volt, 50 kilo ohm, 5 kilo ohm and one diode here. So first we check this diode is parallel with the 5K, right? So whatever VD here will be almost the same with whatever the voltage drop here will be the same. Okay. So if you look at the polarity, say is plus, here is minus. So it go down and then go up, here become plus and minus. And the current also will go here, so here become plus and minus. So we look at this part, here is minus, here is plus, and there is a diode. So you know when the diode to become forward bias, here must be plus and minus, right? But if we look at this condition, it's invert. So the diode here is forward bias or reverse bias? So diode here is reverse bias. So what does it mean reverse bias? Means there will be no current flowing to the diode. So only the current will be 0. But what will be the voltage? The voltage will not be 0. Only the current will be 0. So if you redraw the circuit, so here is a minus polarity. And you have R1, R2, and next there will be no current, means this is when R equals 0, means this one is open circuit. But although this is open circuit, there is a voltage drop inside. Voltage, so we call this one VD. So only the current is happening at the reverse bias, right? So you're applying reverse bias, your VD here still increasing, right, at the negative side. But there will be no current, there will be no current. The I will be 0, but you still have your VD. So now let's do the KVL here. So here you put your KVL around here. So let's say this is I. This is 10K, 10, this is 50K, and this is 5K. So from the KVL equation, start from here become minus 10 plus 5K I. Since this is open circuit, 5Ki plus 50Ki equal to 0. And you can get 10 divided by 55K. So what will be the answer? 10 divided by 55K is 0.182 milliampere. Okay. The question 1, the value of VD. So if we look at this notation here, the voltage, first we need to find the voltage drop across R2, that is V1. So what will be the voltage drop across R2 is 5Ki, right? So what is the I? Is 5K multiplied by 0.182 milliampere. So this one is actually the I. So this one multiplied by 5K become 0.9094. Now what we need to do next is we need to see the polarity. So here is minus and plus, but your VD is plus and minus. So what is the relation between V1 and VD? V1 is equal minus VD. So you got your VD is actually minus 0.909 volt. So what does that mean? So means at your reverse bias, the voltage applied at the diode is minus 0.909. So your current at your reverse bias will be 0. That's why this one is reverse bias. Okay. So when you want to solve this question, check first whether your diode is reverse bias or forward bias. Okay. Okay, now let's move to the next question. So this is chapter 2 question. So you are given an A and D, and the temperature here is not room temperature, it is 400 Kelvin. And you are given the band gap, that is 1.1. This is the coefficient of material and the Boltzmann constant. So what you need to calculate first is the intrinsic. So the formula for intrinsic is PT3 over 2E minus EG divided by 2KT. So what is B? So you just need to replace 10 power of 15 Your T is not room temperature, is 400, 3 over 2, exponent, your band gap is 1.1 divided by 2. So your K given here is 86 times 10 power of minus 6 multiplied by your temperature, that is 400 K. Okay, then you can get the answer 4.76 times 10 power of 12. Don't forget the unit cm minus 3. Okay, for part B, where you are going to calculate the junction capacitance. So you just need to apply the formula CJ0 1 plus your reverse bias divided by your VBI minus 1 over 2. Okay, in order to solve this one, you need to calculate first the VBI. So what will be the value of VBI? Is actually, because this is not at room temperature, you cannot use 0.026. So KT over E ln NA ND over NI squared. Okay, so the K here is 86 multiplied by 10 minus 6 multiplied by your temperature here is 400 divided by 1 multiplied by ln your NA is 10 power of 16, 10 power of 17 divided by your NI just now. You need to square root your NI. Okay. Okay, so this is, you are going to learn everything here. So here we are going to solve this one first and then learn. Then you can get here 0.605 volt. Okay, so this is for VBI. So how can you get for your CJ0? So just now your CJ is CJ0 1 plus VR over VBI. So given just now your CJ0, the initial capacity is 1.5 pico. 1 plus your reverse voltage here is 4 volt divided by 0.605. Okay, so the pico here means 10 power of minus 12. So you can get here 0.544 picofarad. Okay, so this is a junction capacitance at the reverse bias. Now let's go to the chapter 1 question. So for your chapter concept, this is a voltage amplifier and this is a Thevenin circuit because your voltage source is series with your R0. You are given the load is 350. Your V out is given 10 volt. Assume the output resistance is 15 ohm and your input here is 100 millivolt. So when you want to solve this question, always use voltage divider. So what do voltage divider saying at the V out? So V out is equal RL divided by RL plus R out multiplied by AV VI. So let's see what is your RL 350 divided by 350 plus 15. What is your AV? AV is the one that you need to find here. Determine the open circuit voltage gain. Because it's saying gain here. So gain is AV. And you know your VI is 100 millivolt. And what is your V out? V out is also given here is 10 volt. Then you can get your AV. The gain is 104.2. And the gain is unitless. Don't put the unit at the gain. So this is the final answer. Open circuit voltage gain. Okay. Now we move to chapter 8. So for this chapter 8, first when you want to solve these circuits, you need to identify whether it is inverting or non-inverting. But for this circuit, it's not even non-inverting or inverting because you have your input at both inverting and non-inverting input. So in order to solve this one, you need to hold to what we call voltage rule and current rule. First, we check the value given. Given here, R4 is equal to infinite. So what does it mean by R is equal to infinite? So it means that the R is very high and the circuit will be open. It's like your capacitor in chapter 5 and 6. Okay. So means here you don't have R4. Okay. So when you don't have R4, then you need to use voltage rule. So the V1 given here is 1 volt. Here is 4 volt. So when this is 1, here become 1. Voltage rule says the voltage here will be the same at both input. When 1 is here, here also will be 1 volt. Okay. So after we pass the voltage rule, then you need to check the current rule. Current rule says the current entering the op-amp is equal to 0. So what will be the current flowing at the R3? Also will be equal to 0, because based on the current rule, no current is flowing inside the op-amp. So next, what you need to do is you apply the nodal analysis. So let's say this is IA, this is I2, and this is I3, and you denote here VA. Okay. Based on the KCL, current entering is IA, current leaving is I2 plus I3. So now what is IA? Based on the nodal analysis, 4 minus VA over R1. I2, there will be no current flowing at the I2, 0, plus I3 is your VA minus V out over VA minus V out over R2. Okay, so since you know here is 1 and there is no current flow here, so this one is being transferred to VA. So now here also become 1. So your VA is actually 1 volt. So become 4 minus 1 over R1 equal to 1 minus V out over R2. Okay, so when you substitute the value, so become 4 minus 1 over R1 is 5K equal to 1 minus, you don't know your V out, divided by 5K. So cancel it, so become 3. 1 minus V out, so V out is equal to minus 2 volt. Okay, now let's move to the last question. There is voltage regulator. So given to power a car radio, so your car radio is your load. So this is your car radio. Your source is the battery, so this is battery. But the battery source is fluctuated between 5% from the 12.5. So in voltage regulator, you will have what we call VPS maximum and VPS minimum. How you calculate the maximum is 5% of the 5% of the total voltage of the battery. So you need to add the original source. How about the V minimum? 12.5 minus the variation of the 12.5. Okay, and then you can get here minimum is 11.875 volt. Maximum is 13.125 volt. Okay, after you got the VPS and min and max, the current in the radio is 10. So this is a load or a source. Radio is a load, so your IL here is 10 milliampere. So you need to be maximum here. And the minimum value of the Zener current is 5 milliampere. So your IZ minimum is equal to 5 milliampere. So that's the only value given in the circuit. So what you need to find is Ri. So first, how you're going to solve this one, you're going to have the loop KVL equation here. Okay, starting from here, minus VPS plus Ri II plus VZ, because this is happening at the reverse bias, right? You are entering here at the negative sign, so this VZ play role. So you can get your Ri is equal VPS minus VZ divided by I total. But what is I total? Is current entering equal current leaving, right? II equal IZ plus IL. So this is IZ plus IL. So this is maximum. If this is maximum, your IZ will also be maximum, right? So if I change this one to minimum, VPS minimum, your IZ also will become minimum. It will follow. So your VPS minimum is 11.875. What is your VZ? Because this is parallel, right? So they are the same. Your VL is given 9 volt. So this become 9. IZ minimum is 5 milli. IL is 10. And then you can get the answer is 191.6 ohm. Okay. So all the best in your midterm exam. If you have any question, do let me know. Assalamualaikum.